Hi again. I hope you liked that first podcast and you've taken some time to get organized. Here's the second one, and it's going to be under 15 minutes because it has to be. So here we are on the two minuses and the two pluses. These ions are very, very common, carbonate and silicate. Okay, so if you look at your periodic table, folks, carbon, silicon, same family, group 14, the carbon family. These have virtually the same makeup. Carbon has 4 valence electrons, silicon has 4 valence electrons, so they behave very similarly. Very, very common ions. Just know these. If you know carbonate, the deal is, though, if you can look at your periodic table and remember, silicate is exactly the same thing. Of course, you have silicon instead of carbon. The next slide appears to be sort of overwhelming, but if you look at it a little bit more deeply, what you're going to notice is that all of the elements that are here are group 16 elements. So sulfur, oxygen, selenium, tellurium, and again sulfur and oxygen are the only other two elements down here. All of these elements are in group 16. If you know sulfate, and you can remember SO4 with a 2 negative charge, then you're going to be able to look down at the next element that's under sulfur and you'll see selenium. These are exactly alike except for the group 16 element has changed. Underneath selenium is tellurium. So all of these are the same. If you know sulfate, you'd know selenate and tellurate. If you know sulfate, since we know our ate and our ite relationships, we would know that sulfite is 1 oxygen less than sulfate. So if you know sulfate, already you know 3 other things. Now, here's thiosulfate, and at first glance you're thinking, okay, so why is that similar? You don't even have the same subscripts here. But if you think about this for a second, if you take the sulfate ion, remember, all of these elements are group 16 elements, and you give away an oxygen, but you gain a sulfur, so instead of 1 you have 2 there, you really just have thiosulfate. Thio means literally to be replaced by sulfur. And some people say thiosulfate, some say thiosulfate. Either way is fine. So 1 ion sulfate, and you can work off of everything else from there. Okay, we have chromate and we have dichromate, and the slide reads almost doubled but not quite. So what do I mean by that? Chromate is a lot like sulfate. So this is sulfate, the previous page that I showed you. This is sulfate, a really common ion. Well, what you can see here is that chromate's just the same. So you have to just try to remember that. Now, di, I'm sure that you remember, means 2. So what I mean by almost doubled but not quite is your chromium from chromate to dichromate doubles from 1 to 2, but your oxygens are almost there. You go from 4 oxygens, not to 8, but just to 7. So what you have to remember is that it's almost doubled. Again, the charge is going to be the same. Whenever we have a family of ions, the charge is going to be the same. So here are 3 that are a little bit trickier. These, thankfully, are not as common as most of the ones that we've talked about so far. They have some little memory devices here to help you. First of all, 2 wheels on an ox cart. So I can't draw this in 3 dimensions very well. I'm really lame at drawing, but if you can imagine, this is the wheel on one side of the cart, and of course there would be another wheel on the back side of the cart. Okay, so here we have a wheel, and this is an ox cart. Why is it an ox cart? Because this ion is called oxalate. Okay, so my 2 wheels on the cart, 2 C's. Now, ox, how many legs does an ox have? Oxygen. An ox has 4 legs. 2 wheels on the cart, C, 4 legs on the ox, O. And the farmer has 2 legs, and he also has this whip, this negative whip here, because he wants that ox to go to town a lot faster to take the goods to market. Okay, now, once again, I think I mentioned this before, but if we have carbon in a compound, or if it's in a polyatomic ion, the carbon will always come first in the molecular formula. If we have hydrogen, like down here, that will come second. And then if we don't have hydrogen, we obviously skip it. And then oxygen is going to come last. So here's our alpha right here, carbon, hydrogen, oxygen. So don't mix those up. On your molecular formula for acetate, C2H3O2 negative. So remember, that was also alpha. So here's a fun one, 4 corners on a Pop-Tart. So we're just going to pretend here that our Pop-Tart is this box right here, okay? So if I've got 4 corners on a Pop-Tart, here are my 4 corners. 1, 2, 3, 4. Here's my Pop-Tart. Well, this one you may have trouble remembering, but 4 H's. So what I say is the Pop-Tart has 4 hedge edges on it. 4 hedge edges. So 4 corners, 4 hedge edges, and if you get a standard box like the kind they used to have in the 60s when I was a kid, then you're going to have 6 in a box oxygen. There's going to be 2 in a foil pack. And I'm sure that you know that these are really bad for you, even though you may eat them anyway. So that's a negative sign. 4 corners on your Pop-Tart, 4 hedge edges, 6 in a box, 2 in a foil pack, and they're bad for you. I'm not lying. Okay, we've got tetraborate now. Tetraborate. Tetra, I'm sure you remember from tetrahedral. Tetra means 4. Okay, so 4 what? 4 boron. So we've got 4 boron here, and then we got a bunch of oxygen. So my motto here is if you don't eat dinner before 7 o'clock, it's too late. In my family, I was the youngest and I had older brothers, and if I didn't show up to time on for dinner, they would have eaten all the food, so I had better get into the house and eat or it would be too late for me. So if you don't eat dinner before 7 oxygen clock, it is too late, and of course that's a bad thing because you don't have any food left, and you probably have to clean the dishes as well. Tetraborate. Okay, so we've got a couple of ions here that don't particularly look polyatomic, but they are. And the reason they're polyatomic is because of these subscripts that we see here. We have a 2 subscript right here, and we also have a 2 subscript right here. So let's look at peroxide first. I'm sure you've heard of peroxide as in hydrogen peroxide. This is the one. If you think about it for a second, you will remember that oxide is actually a monatomic ion. So here's peroxide, here is oxide. Okay, so you can see the difference between these. There's obviously one more oxygen here. The collective charge is still 2 minus though. And what's going on with that is this. You actually have 2 oxide ions, but each of these oxygens has only gained 1 electron instead of 2 electrons. And they're not thrilled about that because that gives them not 6 valence electrons, but 7 valence electrons. And 7 is not 8, so what they do is they bond together much like a halogen would bond diatomically. So much like you would get fluorine double bonded to fluorine, because fluorine, or single bonded, I'm sorry, they'd bond together. Fluorine would bond to fluorine, single bonded, 7 valence electrons in each, but together they would complete their octet. Okay? So it's just like a diatomic molecule. And it is sort of diatomic, but we're going to call it polyatomic. So oxide is monatomic, peroxide is polyatomic. Remember if you have perchlorate, that's 1 more oxygen. Well, in this case, it does mean as well 1 more oxygen than oxide. Okay, we have mercury 1. Do not confuse this with mercury 2. Mercury 2 is monatomic, and that's mercury 2. You can see there's no subscript here. There is a charge, but there's no subscript. Here there is a subscript. What's going on here is very similar to what happened up here, but I made a mistake, so you're going to have to correct this. Put a 1 here instead of a 2, and put a 1 here instead of a 2. Okay, so that was done wrong. So on your paper, make sure that those 2's are no longer 2's. Make sure that they read as 1's. And I'm sorry about that. I hope it doesn't affect your quiz score after break. Okay, so these are 1's. So here's the deal. This is mercury that's lost 1 electron. This is mercury that's lost 1 electron. And they don't like to be alone. So kind of like those diatomic molecules, they are going to be attracted to each other and they're going to bond to each other for stability. So if you look at these, we've got two mercuries, Hg here, that's two mercuries, and we've got a total charge of 1 plus 1, and that's going to equal 2 plus. Okay, so mercury 1 is polyatomic, mercury 2 is monatomic. And if that's not confusing, I don't know what is. Okay, so we've got the 3s now. And there was one more 3 that was added to your paper. You could add probably a number of things to your paper. I didn't add all of the ite ions that I could have added. So what you can figure out from this is if you know phosphate, PO4, 3 negative, you would also be able to figure out phosphite. And phosphite is not going to be on your quiz, so don't worry about it too much, but after your quiz you will have to be able to figure it out. So what's going on here, as you would be able to reason, is that if phosphate is PO4 negative 3, phosphite would be 1 oxygen less at PO3 negative 3. Now back to these two, phosphorus and arsenic are in group 15 together, so group 15. And what you can see is they have the exact same pattern. 1 atom bonded to 4 oxygens with a charge of negative 3. Both of these form a tetrahedral structure. The unfortunate part about this is that nitrate does not fit the pattern. Nitrogen is also in group 15, but as you can see, this is the nitrate ion. It doesn't fit this pattern. Unfortunate, but it's true. Okay, so along with that phosphite thing, you should be able to figure out perphosphate, you should be able to figure out hypophosphite, you should be able to figure out perarsenate, arsenite, hypoarsenite, but those will not be on your quiz. The only thing that will be on your quiz are these original ions that you've been given, but you will have to know some others periodically. So there are a couple last minute additions. These will not be on your quiz. What I'd like to point out to you, you've probably added these already, and if you haven't added all of them, you probably want to. If you look at the first one, this is the hydrogen carbonate ion, and you had this in your ion lab. We also call it bicarbonate ion, and if you understand how this is formed, then you're more likely to remember it. So if this is carbonate, and what you do is you add a proton to it, a hydrogen ion, what's going to happen here is this. You're going to add a positive, so that will give you 1 less negative. And so what we do is we simply call this hydrogen carbonate or the bicarbonate ion. Okay, the hydrogen sulfate ion is the same type of logic. You have sulfate. Here's your sulfate ion. Okay, so we're going to add a proton right here. If we're adding a proton, that means that this becomes a -1 instead of a -2. Hydrogen sulfate ion. We have the same thing happening here with the hydrogen phosphate ion. So here is phosphate, PO4, 3 negative. If we add a proton, our charge becomes 1 less negative. We have 1 less electron here because this proton offsets it. This guy here is dihydrogen phosphate, and you may not have added this yet, but please do. What's going to happen here is this. You have PO4, 3 negative, from which it's based. That's going to be your phosphate, but instead of adding 1 proton like you did here, you would add 2 protons, and so what that tells you, dihydrogen, you've got 2 protons here. However, since you've added 2 protons, now you just have a negative charge instead of a 2 negative charge. So that's the formation of those last minute additions. Those won't be on your quiz. I hope you do well on this quiz. People who do well on this quiz are successful for the rest of the year. And unfortunately, those who don't are going to struggle and struggle and struggle until they figure out that they just have to sit down and learn these things, and they always regret not having learned them in the first place. We could bring in people to talk to you from last year, the year before, and they would all tell you the same thing. The most important thing to do in this class in order to be successful is to learn these polyatomic ions and practice, practice, practice. Have a good winter break and take care. Be good. Hope you get lots of presents and all that stuff. You are lying to me.